We're here at b2p2.com working some calculus problems, and we're in the section continuity and one-sided limits, and we're actually in that section there. Well, let's take a look at what we're doing here. We got the limit as x approaches 4 coming in from the right hand side. That's what this little plus sign means. Here we're coming in from the right of the absolute value of x minus 4 over x minus 4. So let's bring this up and rewrite. We have the limit as x approaches 4 coming in from the right hand side of x minus 4 over x minus 4. Let's just sketch out what this graph looks like. And how about we make the graph green? How's that? That is definitely not green. Let's try that. Okay. Well, it's not to scale anyway. This should be at 1 and that should be at -1 down there, and it's obviously not scale. Okay, so we've graphed it out. There are just certain graphs that you should know. You should know what the graph of the absolute value of x over x is going to be, right? This is going to be, right, open circle, and the only difference between this graph and this graph is it's been shifted 4 units here to the right. It's been shifted 4 units to the right. Now we're focusing in on coming in from the right of this graph. So we're coming in from the right hand side because this is a plus sign. So as we take numbers and get closer and closer and plug it into the function, as you can see, this number here is staying constant. It's staying at 1. Alright, so no matter how close we get to 4 from the right hand side, this limit is going to be 1. Now if this were a minus sign, we would be coming in from the left, right, plugging numbers in, getting really, really close to 4 from the left, and of course it is -1, right, -1. So we could say then that this limit is +1. And sometimes on these right and left-handed limits, that's what you probably need to do. This would be like, plug in 4.001, something kind of close to 1 from the right. Plug it in and see what this is, what the limit is actually approaching. Now, this is a lot like how we did it when we were evaluating limits numerically. Right, evaluating limits numerically. One other thing, since this is a section on continuity, we can see here that this limit is not continuous when x is equal to 4. Alright, and this is something a little extra here. C in this particular case would be 4, and this does not exist, first off. So that fails. We plug 4 into the function here and we get 0 over 0. So that fails, period. We would also check if that did exist. We would check to see if the limit as x approaches c of f of x, to see if this limit exists, and as you can see here, it fails also. So this does not exist either. This limit doesn't exist. And let's say that this limit did exist. Let's say, for example, at 5 we plugged in, well, f of 5 is 1, so that does exist, right? And taking the limit of f of x as x approaches 5, that exists, and that's also 1, and both of these numbers are the same, therefore it's continuous at x equals 5. So the only place that this function is not continuous on the entire real number line is going to be here at 4. That is the only place that this function is not continuous. Alright, so a little on left-handed limits, right-handed limits, and continuity.